Hi Pre-Calc, going over your homework, section 2.5, number 79. All they want you to do here is do Descartes' rule of signs, okay? It's not the whole long problem. We're just focusing on this one skill. All right, so for the number of positive real zeros, it's the variation in sign of the original function. So from here to here is one change because it's positive to negative. And from here to here, it's no change because it's negative to negative. That doesn't change sign if you go from negative to negative. So the number of positive real zeros is 1. And since I can't subtract 2 from 1 and stay with a non-positive number, sorry, non-negative, right? I can't subtract 2 because that would be -1, and you can't have -1 positive real zeros. It doesn't make any sense. So I can't then do the subtract 2 for the complex conjugates. All right, so again, variation in sign of the original. Now, for the number of negative real zeros, that's the variation in sign of g of negative x. So remember, you first have to create g of negative x. So everywhere you see an x, you have to replace it with negative x. It's a substitution. Right? Everywhere I see an x, I put a negative x as a substitution. And now I'm going to simplify this. So negative x cubed is negative x. So if it's odd, it changes sign. If it's even, it doesn't change sign, right? Because a negative x squared is positive x. And negative 3 times positive x squared is negative 3x squared, right? Right, because when this comes out as a negative x cubed. When this comes out, it comes out as a positive x squared. Right, so this one changed sign where this one didn't. Okay, so now I can do the positive, negative, real zeros. I look at the variation of sign. So from here, I go from a negative to a negative. There's no change in sign here, so that's 0. From here to here, I go from a negative to a negative. There's no change in sign, so it's a 0. So there, in this problem, there's no negative real zeros. So since this is a third degree, it has at most in the complex system 3 zeros. So right now, the only scenario we have, I just write it out real quick for you. The only scenario we have is that it has 1 positive, no negative, and 2 complex, and that's what adds to 3. So there is only one case for this one. Okay, I hope that helped. This is a part you're trying to do right now. Number of positive and negative real zeros. I probably at some point will do another one since that had you didn't get to use that -2, minus an even integer rule. Okay, gang, catch you again. Bye-bye.